Okay, I'm going to talk about how to establish the whole using pictorial representations. So before we can come up with a fractional value for any picture that we draw, we first have to establish the whole. And so the way that I'm going to do this is I'm going to say, okay, let me say that this value right here is equal to one whole. Okay, you can see the usefulness of using graph paper with students. Okay, so if I'm using this as the whole, then we might ask ourselves, okay, what value is this right here? Okay, so what value is that? So you might look at this whole piece that I drew here, and you might say, okay, here is one piece here, here is another piece here, and here is a third piece here. And those are three equal sized pieces because each of them has two squares. And so that means that this value right here is going to be equal to 1/3. It's really important that we write the sentence that goes with that. And that sentence is, because three equal pieces make one whole. Now, I could just have easily decided that I was going to establish the whole like this. I could have started off by saying that this is equal to one whole. If I did that, if I started this whole thing differently with a different whole, and then I asked, okay, if that's the case, then what value is this right here? Trying to figure out the value of this pictorial representation. So now I look at taking this representation right here and comparing it to the whole. And to do that, I notice that I have 1, 2, 3, 4 equal pieces. So this is now equal to 1/4. And that's because 4 equal pieces make one whole. Now, a reasonable student would come to you and say, hold it, how can this, which is 2 squares, have a value of 1/4, and this, which is 2 squares, have a value of 1/3? How is that possible? It doesn't make sense. It seems like you're contradicting yourself. And the answer to that is, a fractional value of a drawing only has value in relationship to the whole. And so, before I can tell you the value of a picture, you have to show me a picture of a whole. That's a really important thing to establish with students. Once you do it, and it takes time, it takes days, weeks, months to develop a sophisticated understanding of this, and you have a lot of activities that you have to have students go through to try to reinforce this idea. But once you do it, now you can ask them to do things like this. If this is one whole, now let me be really clear what I'm talking about. And the way to do that here, I'm going to separate these two pictures here. And say, all right, if this is the whole over here on this side, then what value is this going to be? Now what we want students to do is to come up to this drawing that we made before and say, well, here's 1/3, and here is another 1/3, and here is another 1/3. We might even say something like, well, every 2 squares has a value of 1/3 as long as this is my whole. So I'd look here and say, well, how many 2/3 or how many 2 square boxes can I make? So here's one and here's another. So I'm going to call this 1/3. Again, that's only in relation to this whole. And I'll call this one 1/3. Again, only in relation to this whole. And so if that's the case, as long as we're talking about this whole, then the value of this is 2/3. Okay, so that's one activity you can do with kids, is to ask them, given a drawing, what's the value of that drawing? What's the fractional value of that drawing? Another way is, could you make a drawing of, let's say, 2 1/3. So if that's the case, then I'll go up here and say, okay, to make a drawing of 1, I need 6 squares. So I'd say, let's see, there's a drawing of 1, because it has 6 squares, just like my hole up here. So this is 1, but I want another 1. So here's another 6 squares. That's also 1, but I need an extra third, and to get an extra third I need 2 squares. So now what we have is, we have 1 plus 1 plus 1/3. This is a drawing of 2 1/3. We want students to understand that. But if I were to draw the same drawing over here, let's see, would I be able to, well, let me just put it over on this side. Let me just ask another question, and then we'll do a more advanced questioning later. But over here, what value then is this? If I were to make this drawing, what value is this drawing? Okay, again, 2 squares is equal to 1/4, as long as we're talking about this side here. So this value right here is 1/4. This value right here is 1/4. And this value right here is 1/4. And so the entirety, the total of this, that's equal to, let's say, 1/4 plus 1/4 plus 1/4, and that's a value of 3/4. So we would say that this picture has a value of 3/4. We could even say, make a drawing of, let's call it 1 and not 2, but 3/4. 1 3/4. Again, we want students to refer to the whole. So to make a picture of 1, we have to duplicate the picture that's up there. Let's see, I think I got it right. That's 1. And then I need 3/4. Remember that to get 3/4, I'll add 3 1/4 pieces together. And so this is 1. This is 1/4. This is 1/4. And this is 1/4. When I add those together, I'll get 1 3/4. Let me be clear that this has a value of 1 because we've said that 1 is equal to 8 squares here. And this has a value of 1/4, 1/4, 1/4. And now we have created a picture of 1 3/4. All right, let me stop here for a moment and make some comments, kind of important comments that I think are really critical to understand what we're doing. First of all, we want to establish what value is a whole. On this side, 1 whole was equal to 6 squares. But on this side over here, 1 whole was equal to 8 squares. Over here, 6 squares. This idea of flexibility in defining the whole, that is a very huge conceptual hurdle for most students, and it takes practice. The second thing that I've done here that I really encourage you to think about and use as much as possible is writing a sentence right here. A sentence that describes why it is this value right here is 1/3. It's 1/3 because there's 3 equal pieces that make 1 whole. 3 equal pieces that make 1 whole. That's what we mean when we say 1/3. Okay, this piece is so critical that you write it down and leave it for students to refer to, and then train them to do it for themselves. This is the part where English learners, and for that matter, any student who is learning to use academic language in mathematics, has to repeat this multiple times. And the easiest way to repeat something with this precise language is to write it down and just point to it and say it over again. Over here, what I've done is the exact same thing. Notice the structure of the sentence is the same. Make it simple, make it repetitive, and make it easy reference for students. Students then become proficient at this when they can write this themselves. All right, that's enough for this video. We'll talk later. Thank you for listening.